Alright, so today we're going to cover some tricks in multiplication and division. So our first trick is to know the laws of multiplication. The commutative law of multiplication states that it doesn't matter which order you multiply in, you're still going to get the same answer. For example, 2 times 5 or 5 times 2 still equals 10, right? 2 times 5 is still 10 and 5 times 2 is still 10. Alright, the associative law of multiplication states that it doesn't matter which way you group the numbers, the solutions are the same. For example, 2 times 3 times 7, it doesn't matter if you group it as in 3 this way, as you group 3 and 7 together, or 2 and 3 together, you're still going to get 42 as your solution. And the distributive law of multiplication states that it doesn't matter whether you add or subtract first, or if you distribute the A into the brackets, you're still going to get the same answer as well. For example, if you do 2 times 3 plus 4, or you just do 2 times 3 plus 2 times 4, you're going to get 14, no matter what. Alright, so let's cover the multiplication tables of 10, 100, and 1,000. Sometimes it helps us to work faster in multiplication and division if we are familiar with the multipliers and multiplicands of 10, 100, and 1,000. So this is what a multiplier and a multiplicand is, right? These are just really nice to know and to memorize because these are very easily identifiable, and if you can identify them, you can work faster. Alright, so our next method is to know prime factorization. But before we can cover prime factorization, let's review what a prime number is. A prime number is a number that can only be divided by the number itself and 1. 2, 3, 5, 7, 11, 13, and 17 are some examples of prime numbers. A quick example for a number that isn't a prime number is 14. 14 is a composite number because it can be divided by numbers other than 1 in itself. It can be divided by 2, it can be divided by 7, right? It can also be divided by 1 and 14 as well. Let's go through prime factorization now. The method I'm going to show you to prime factorize is the factor tree method. So basically what you have to do is you have to find some number that goes into 210. For example, 10. 10 goes into 210 21 times because 210 divided by 10 is 21, right? So we have two numbers and they're going to branch off this number, 10 and 21. Alright, but these numbers, they're not prime numbers, right? There are numbers that can go into these, right? So for 10, 2 can go into 10 5 times. And if you remember from the previous slide, 2 and 5 are both prime numbers. And 21 isn't prime either. 3 can go into 21 7 times. And 3 and 7 are prime numbers. So the prime factors for 210 would be 2, 5, 3, and 7. Knowing these factors can help you divide if you're looking for something that could go into a number, or maybe in some cases it can help with multiplication. Alright, so let's talk about the multiplication of 11 and 101. To multiply a number by 11, just add the number to the product of that number and 10. For example, if we wanted to find 32 times 11, instead of writing it out, right, like 32 and 0, 2, 3, right, we can identify, there's a pattern there. We can see that it's just that number plus the number times 10, right? So that's the pattern for 11. And when two-digit numbers are multiplied by 101, the four-digit number product is simply the repeat of the two digits. Alright, so let's see 63 and 101. 100 multiplied by 101. That is 6,363. Now let me just show you the long method so you can see why this makes sense. So 303,606. You add them together, it's 6363 because the zeros land exactly where the spacing is. Alright, so our final pattern for today is unusual multiplication patterns, right? So if the sum of the digits in the ones places of the two-digit numbers is 10, and their digits in the 10 places are the same, you can work out the product using the method shown below. Note that these numbers 2 and 8 have to be 10, so it isn't applicable to every single number that has the same tens digit. Their ones digit has to add up to 10. Alright, so we're going to do 72 times 78. So to find the first two digits of the product, digits in the this is the formula to get this. So digits in the 10 place times digits in the tens place plus 1. So 7 times 7 plus 1 is equal to 7 times 8 is equal to 56. So we know it's 4 digits. We know 56 goes in the first slot. And to find the last two digits of the product, we have to use this formula. Digit in the ones place of the first number times digit of the ones place on the second number. So we can see that 2 times 8 is equal to 16. We bring the 16 over here, and the answer is 5,616.